Okay, 3.4b, we're going to do some more solving for y, but maybe in this small handful of examples, we'll just see like some other possible, twists and turns and things that you could have to deal with, like these parentheses, in order to end up getting y by itself and move everything to the other side. That's not the y. Of course, we'd have to clear the bubble first. That's pretty much always our first step if it's there. So -4 distributing here. -4 times x is going to be, of course, -4x. That's just... And then -4... It's kind of sloppy. I don't know what happened here, but... -4x. And then we multiply -4 to the positive 2y. We get -8y. So yeah, we clear the bubble first, and now we can start, in this example anyway, getting rid of stuff that's on the same side as the y. Like, we want to leave the y all alone. We start by getting rid of this separate -4x term by adding 4x to both sides. That leaves on the left side -8y. And again, just like last section, 16 plus 4x, those do not combine together. They're not like terms. One has an x, one does not. They don't combine together. They remain separate terms. And even though you could write it as 16 and then the 4x, I'm going to write the positive 4x and then the positive 16, putting the x term first over there. And now what do we do? Well, we would divide both sides by -8, and then that would leave y by itself on the left. Dividing both of these terms by -8, you have to know your division, I guess. 4x divided by -8, so really 4 divided by -8 with the x along for the ride. Is it clean division? 4 divided by -8. Remember, it's not -8 divided by 4. It's 4 divided by -8. There is a difference. So 4 divided by -8. Is that clean division? No. It's not clean, right? So you leave it as a fraction, okay? But can the fraction at least reduce? 4 over -8. Can that at least reduce? Yeah. That reduces to -1/2. And then the x, which is there. And then you have positive 16 also divided by -8. That is clean division, -2. So our final answer here, solving it for y, is y equals -1/2x -2. This one, ooh, the y's over here. Now, like I probably said last section, I know I definitely said it in the video, we like the y on the left. It just convention and just the natural what would make sense. So I guess what we could do, just bear with me here, what we could do is add 2y to both sides to move this term over here, and then that would be like we'd have a 0 over here. It would just be 0. for a moment. But then we would like subtract 6x to the other side, and we would subtract 12 over to the right side, and then we would finish getting y alone, with y being on the left side. Well, what I'm going to do is I'm just going to get y alone on the right, and then maybe just switch the equation around the way we've probably done already in class. So in order to get y by itself over here, we divide by the negative 2, both sides. So that leaves y alone, and then 6x divided by negative 2. Hey, that's actual clean division. 6x divided by negative 2 is a clean negative 3x. And then 12 divided by negative 2, that is also clean division, minus 6. So we have negative 3x minus 6 equals y. I would not have a problem with this, actually. I know how much I've said we like y on the left. It doesn't mean I would mark you wrong for having this as like some kind of final answer, but I'm sure a lot of you will just want to kind of like just switch the equation around and just, you know, rather just say it backwards, you know, y equals negative 3x minus 6. Okay. One or two more examples. Oh man, what a plot twist. What are we ever going to do seeing a y on both sides? Well, first of all, is there any like terms already together over here? No, none of these will combine with each other. And nope, not over here. So, gee, what if we just get the y's together over there? And so that's going to be 2y. And then what remains on the right side, see, these are like terms. They do combine together to make 2y. And what remains on the right side is negative 2x plus 7. And now this should look very much like an example we've already done, okay? So now we have 2y remaining. And can we subtract 3 from negative 2x? No, of course not. But we can subtract 3 from the 7, and that'll be plus 4. And now, of course, we divide both sides by 2. And again, for like the 10th time, you got to divide the entire right side by 2. There's 2 terms over there to be divided by 2. And hey, another clean division. Negative 2x divided by 2 is negative 1x, or just negative x. Also got to divide the 4 by 2 to get that. And that's it. One more example. One more example. What are we going to do here? Well, I only see y one time, and all right, so let's move some furniture around. Let's get that out of there. So we'll have a 4y minus 8 left over. And can we do 4x minus x? Are those like terms? Yes, they are. 4x minus x, or in other words, 4x minus 1x. Remember, technically there's like a, so it'd be 3x. And now we keep going to get y all alone. Can you do 3x plus 8, as in can you combine those together? No, they're not like terms. This has an x, this does not. So we just leave them separate. So 3x plus 8 is just 3x plus 8. And then finally, we divide And can you do 3x over 4 cleanly? No. Can that fraction reduce? No. So it's just 3 over 4x. And then you got to do the 8 divided by 4 also, which is clean, plus 2. And this is where we stop. There's another page though. That's it for 3.4b.